Good afternoon, everyone. I'm John Spence, Chair of the Department of Renewable Resources, and I'm pleased to welcome you all to the third annual Bentley Lecture. We started this ball rolling about 3 years ago, hopeful that we could maintain it and have it continue as an annual event. And I'm very pleased that it seems to have developed the required momentum. And it's nice to see friends both from the academic community and from outside the academic community here, because sustainable agriculture is something that's an issue for all of us in this province. It's appropriate at this time of the year, so close to harvest time and just after our Canadian Thanksgiving, that we begin to think about something that we don't pay a lot of attention to. And that's what we take for granted on the supermarket shelves. I think lots of times most of the Canadian public tends to imagine that this all appears like magic. Of course, those of us in the business know that it does not, that it requires a lot of hard work from people. And over the last 50 years or so in Western agriculture has required the expenditure of an enormous amount of petroleum products. We know that this is not unlikely to continue. We should have listened to the message that Dr. Bentley was among the first of Canadian researchers to push forward, that we had better think about sustainability in this enterprise. And this is why we have kicked this lecture off, to draw attention to these aspects of agriculture, and hopefully to help us rebuild some momentum in this area and develop a program that will turn out the kinds of professionals who will guide us forward into the new era of agriculture. So before I introduce or call Dr. Juma to the stage to introduce the speaker for today, I'd like to just say a few words of thanks to the many people who have been involved in putting this lecture together and making it happen. Again, Norella has been kind of instrumental in driving this, and I very much appreciate his efforts. But this is an undertaking that has involved a lot of people, our IT staff, our non-academic staff, our secretaries, and so on. And we appreciate the work that everybody has done to make this afternoon and evening possible. So without further ado, or taking up time for the message that you really want to hear today, let me call Norella to the stage to introduce our speaker for today, Dr. Juma.
There have been fantastic advances made in agriculture over the past 50 years. And the prosperity we see is a result of a concerted effort to advance agriculture from all aspects: sustainability, product development, marketing, etc. However, with all this comes a need to integrate information, to take a systems approach where we start looking at the very complex problem and the challenge of the industry of agriculture. And now it is a global enterprise. I have brought here 2 cans which contain corn, and this is something quite ordinary. This is green giant niblets whole kernel corn, and I think this is it is at least packaged in Canada. I found this no-name brand of whole kernel corn, and as expected, this would be 10 cents cheaper. But what really drove my attention to this is that this no-name brand is a product of Thailand. And when you're thinking about energy and resources and how is it possible to get things like this? This is a simple illustration of a systems approach which is now needed to understand how agriculture is functioning in the global environment. Our speaker is a person who has been looking at a big picture. His background is in philosophy and theology, and he has taught in an academic environment for 15 years. Then he was called back home to the farm, where he wanted to try out something he learned, as he told us, from his students about organic agriculture. He has been into this field, and he has made remarkable discoveries. And at the present time, he is at Iowa State University and the director of the Leopold Center of Sustainable Agriculture. So I've given you his two great attributes. He is a farmer and as well as the director. His talk today is, as you can see here, is presented on the PowerPoint slide. And will you please join me in welcoming the third Bentley Lecturer of Sustainable Agriculture, Dr. Fred Kirshenmann.
Well, thank you, Norella. I want to first of all express my deep gratitude for the invitation to join you today. And I'm especially grateful because of the incredible hospitality that you've all shown me in the last 2 days. And I've learned a lot, and particularly delighted to learn that there's so many parallels between the history of Alberta and North Dakota, which I still regard as my home, since my farm, of course, is there, which I'm still managing. I'm just doing it by cell phone now, which is an interesting challenge. But to learn about those many parallels in our history, how the regions were settled and how it evolved, and the kind of agriculture that developed in our various homes, and also to learn more about Fred Bentley and to meet him last night. And I do want to say, with all genuineness of heart, that I am deeply honored to be able to present this lecture in his name. He is truly an incredible individual. What a treasure you have had here and continue to have here. So let me begin. And as Norella said in the title of my talk, we have agreed on is, can we develop a sustainable agriculture for the 21st century, given the challenges that we face? And of course, in trying to answer that question, we should, at least first of all, decide what we mean by sustainable agriculture. And of course, as you know, there have been these large debates about what sustainable agriculture means, and very often we get into these pissing matches about if you do these 6 things, you're sustainable, and if you don't, you're not. And we need to get beyond that. And so I've come up with what I regard as a fairly simple definition, and that is, an agriculture is sustainable if it maintains its productivity indefinitely. And of course, we're faced with some situations now where it's not just maintaining productivity, but in fact, increasing it, at least for a period of time. And so if we can agree that that's sort of basic broad working definition, then the next question that we have to ask is, wait a minute, I'm doing something wrong here. There we go. The next question we have to ask is that if the agenda for sustainable agriculture is to maintain productivity indefinitely, then what does it take? What does it take to maintain productivity? And I still think that this brief paragraph from Wendell Berry's essay, Nature as Measure, says it as well as anything that I've run across. And Wendell says, if agriculture is to remain productive, it must preserve the land and the fertility and ecological health of the land. The land, that is, must be used well. A further requirement, therefore, is that if the land is to be used well, the people who use it must know it well, must be highly motivated to use it well, must know how to use it well, must have time to use it well, and must be able to afford to use it well. Now, I have to confess to you that ever since I read this almost 15 years ago, I've been asking myself whether or not we could take anything off the list and still meet that objective of maintaining the productivity of agriculture indefinitely. And I cannot see anything that we can take off the list and still accomplish that end. And I've always challenged people, and I will challenge you as well, if you see something on there that you think we can take off the list, I want to know about it, because that means our task becomes a little bit, less complex than I think it is. But I think that, to me, pretty much describes the task ahead of us. So, if that's the agenda ahead of us, then the next thing we have to ask is, what kind of capital do we need? What kind of capital do we have to develop in order to meet that agenda? And I think there are 4 kinds of capital. There's, first of all, the ecological capital. The land has to be used well. We have to maintain the ecological health of the land. And where we are now, as I will point out in a minute, is in fact we have to restore the ecological health of the land because it's already too damaged now. So that's the ecological capital that we have to develop. Secondly, we need human capital. We need people who know how to use the land well and who know it well. And so that means a particular kind of farmer. It means a particular kind of connection on the part of the humans who are on the land, who are managing the land. So we have the human capital to develop. And then thirdly, we have the social capital. People must be highly motivated to use well, and that's a social agenda. How do we develop a population of farmers and others who use the land to be motivated to use it well? What kind of social agenda, what kind of social issues do we need to put in place in order to have people who are highly motivated to use the land well? And then we need the financial capital. They have to be able to afford to use the land well. And what I want to suggest to us this afternoon is that we have a lot of work to do to develop these various types of capital if we're going to meet that goal of maintaining productivity. Now, certainly, the modern industrial agriculture that we've had in place for roughly the last 50 years has claimed that it is sustainable, and we want to honor that. Because if the definition is to maintain productivity, we've done a pretty good job over the last 50 years. And we have doubled and tripled the yields of our major cereal crops, corn, soybeans, wheat, rice. And we've pretty much maintained that. Some of the more current data globally indicates we may be losing a little bit of ground in terms of world productivity, but pretty much, we've been successful in maintaining it. But the difficulty, I think, is that this system of agriculture, this modern industrial system of agriculture, is based on a set of assumptions that I think we now need to question. And the first of those assumptions is that production efficiency can best be achieved through specialization, simplification, and concentration. And those are the 3 principles of any industrial economy. They were principles outlined by Taylor in his scientific management treatise back in the early 1900s. And it was Henry Ford, when he developed the assembly line for manufacturing automobiles, that used Taylor's principles and applied them to manufacturing. And of course, as we know, in most manufacturing, that has really worked very well. Henry Ford was able to, for the first time, produce automobiles that were affordable by almost every citizen. But he operated by these principles. He once famously said that people can have any car they want as long as it's a black Ford Model T. Now, that's the specialization piece of it. And of course, he simplified the assembly line so that he could use unskilled labor to produce the automobiles, and of course did them on a volume, so they had the kind of economies of scale to reduce that price so that the average citizen could buy an automobile. So we know that in manufacturing and in many of other human activities, these principles are very sound. We have now applied those principles to agriculture, and one of the things that I want to have us think about this afternoon is whether or not those principles, clearly they have worked, as I've said, because for the last 50 years we've increased our productivity, enormously efficient systems. The question we have to raise is whether they can continue to work given the challenges that we're facing now, and we'll get into those. The second assumption that modern industrial agriculture operates on is that therapeutic intervention is the most effective way to control undesirable events. So if you have a problem on your farm, we believe in the industrial system the best way to deal with that problem is bring a counterforce in from outside the farm and attack the problem and get rid of it. So if you got a pest problem, you bring in a pesticide to get rid of the pest. If If you are lacking fertility, you bring in fertilizer from the outside to supplement the soil system to provide that fertility. So it's that therapeutic intervention approach that we have decided in industrial agriculture is the most effective way to deal with these undesirable events that are a part of any system. And then the third assumption is that technological innovation will be able to overcome all production challenges. We, I think, firmly believe now that any problem that we have, we can develop a technology to solve it. And we continue to operate on the basis of that faith. And then finally, the fourth assumption is that we believe that control management always works. And that's an assumption that goes back to the beginning of the scientific revolution in the 17th century, in which it was assumed that nature essentially was a mechanical arrangement of parts, that we could control and manage to the benefit of human species. And so control management functions. And again, that's an assumption that I think we want to at least explore, and I would say question. So, one of the reasons that this approach to agriculture, this modern industrial approach, has been so successful over the last 50 years is because we've had a range of resources that have been available to us, which now, I would argue, are in decline. And the first and perhaps most important of those, of course, have been cheap fossil fuels to fuel that whole system. And if you think about it, our modern industrial agriculture system is dependent on fossil fuels at almost every level. Our fertilizers, our pesticides, our farm equipment, our irrigation water, our traction fuel, all of that is fossil fuel based. And we have been able to make that therapeutic intervention successful and control management work, etc., because we've had these technologies and tools based on cheap fossil fuels that we've been able to import into the farm to solve the problems. And even though those problems have sometimes been increased, we all know that when you use a pesticide to control a pest, you never kill all the existing pests, so you end up with some resistant pests that you then need more aggressive pesticides to deal with. And at the same time, you're also killing some organisms that previously served to keep some pests in check, and so you have a further emergence of pests. So in some sense, we're creating the problem that we're trying to solve, but as long as we've had cheap fossil fuels to keep inventing those new technologies, to keep dealing with the problem, we've been able to make it work. The question now is, can we continue to maintain productivity using this model, given the fact that we have now either reached peak global oil production or will reach it in the next couple of years, which is all oil industry analysts now are telling us that that's about where we're at. And of course, we're already beginning to see the pressure on farmers from this situation that we're in. My economic colleagues at Iowa State University tell me that next spring, 2006, that farmers in Iowa will have to spend about 20% more to put in that 2006 crop than they did the 2005 crop. Because when the price of a barrel of oil goes up $10, it's not just the diesel fuel you put in your tractor, it's your fertilizer, it's your pesticides, it's your farm equipment. All your costs go up. And so we've seen a 20% increase in cost, or will see a 20% increase in cost, despite the fact that the price of a barrel of oil, sure, it's increased, and we all see that at the pump when we fill our cars with gas. But nevertheless, this is only the beginning of where we're headed in that direction. So a question we have to ask ourselves is whether or not this system is still going to be able to maintain productivity when we can no longer rely on cheap fossil fuels. And then there's environmental degradation. And I'll go into all of these in a little bit more detail. But the issue around environmental degradation is that we are now at a point where that's obvious, where that's visible. It's no longer a matter of having a few scientists saying, gee, we may be having too much nitrogen, spilled into the environment, and that could cause us some problems. We now have a hypoxia zone in the Gulf of Mexico that at its peak in 2002 was 8,200 square miles in size. And I can tell you that the shrimpers in Louisiana are saying to the farmers in Iowa, you guys can't do that anymore. This is affecting our business. We're farmers too. And so you got to do something about that. So the environmental degradation is now visible to a point where we have to do something about it. So again, can we figure out a way that industrial agriculture can continue to be, to maintain productivity given those new realities? And then we have the whole issue of climate change that's coming at us. And that isn't just due to global warming, wherever you may stand on that, but it seems to me now it's pretty hard any longer to deny that that's happening, and that's going to have an effect on the climate, primarily in terms of more unstable climates. But here's the real clincher. The kind of climate that we've had since about 1940, these relatively stable climates which have been favorable to agricultural production all over the planet since 1940, that's very unusual in terms of the history of climatology. Climates generally on this planet have been much more unstable than what we've experienced in the last 50 years. And if you want to read a book about that, Stephen Schneider, way back in 1976, published a book called The Genesis Strategy, in which he pointed out, documented historically, that this is the case. And he said even back then in 1977 or 1976, this is not normal. We are going to move toward a future, and this was before global warming was the big issue. We're going to move to a future in which climate is going to be much more unstable because that's the normal pattern for our planet. And then on top of that, we have essentially a bankrupt farm economy. And we'll go into that in some detail in a second here. But our farmers do not have the economic flexibility to make a lot of choices for change here and take a lot of risks in terms of meeting these challenges into the future. And so we have to deal with that. That's part of that financial capital issue. Okay, so let's look at these four challenges in a little further detail. The problem with the energy issue is not just that we're running out of fossil fuels. The problem is that we're running out of fossil fuels and there is no alternative. There is no alternative supply in the pipeline that is going to get us anywhere near what we've gotten used to in fossil fuels in terms of energy efficiency. So this is a chart put together by Marty Bender at the Land Institute, who's been studying our energy situation in relationship to agriculture for the last 20 years, looking at total energy flows, and that's the important part. When you look at total energy flows, here's where we are. In oil and natural gas in the 1940s, we were getting about 100 units of energy for every 1 unit of energy that we invested in making that energy available. Now that's not ever going to happen again on this planet in terms of energy unless somebody comes up with a brand new technology that none of us are aware of at this point that's going to give us that kind of cheap energy again. There's nothing in the pipeline currently that looks like it's going to get us anywhere near there. So we have gotten used to, not only in agriculture but our other human economies, with an energy source that was so efficient that we were getting that kind of return for our investment. Now, as Marty points out already, by the 1980s, we were down to about 1 to 12. And that's the direction that we're headed in with fossil fuels. But then look at all of the other energy supplies that are currently in the pipeline, whether you're looking at nuclear, at renewables, at solar-based electricity. You're looking at BESS again at about 1 to 13, and that's in wind and hydroelectric dams. That's the future we've got to get used to. And so, as Marty points out, by giving us simply one example in terms of energy conservation, and that's our homes, when you invest in double-pane windows or in ceiling insulation, etc., in other words, when you invest in conservation, then you start to get real return for your investment again. Now, I think there's a clue in that in terms of agriculture. If we don't have agricultural systems for the future going beyond the industrial fossil fuel era, that depends on energy conservation, then we're probably going to be in trouble. So what kind of energy systems that are based on conservation can we develop that give us the kind of farming systems that are going to meet the challenges of the future in order to maintain productivity? That's, I think, where we're headed. Okay, on the environmental degradation piece, I think that one of the most significant documents to appear in the last 50 years has been this summary report from the United Nations called the Millennium Ecosystem Assessment Synthesis Report. It was released in March. I understand the full report is supposed to come out sometime yet this month. But here's the core find, and this is a report that was developed by 1,360 of our leading scientists from the world, 95 countries. So this is not, a group of environmentalists that are just out to scare us about what's happening. These are some of our core scientists, and looking at this issue for over 10 years, came up with this report. And here's their core finding. Over the last half-century, humans have polluted or overexploited 2/3 of the Earth's ecological systems on which life depends, dramatically increasing the potential for unprecedented and abrupt ecological collapses. approximately 60% of the ecosystem services evaluated are being degraded or used unsustainably. Most ecosystem changes were the direct or indirect result of changes made to meet growing demands for ecosystem services, in particularly the growing demands for food, water, timber, fiber, and fuel. You get the message here? It's been the way in which we have done our agriculture and secured our fuel for agriculture and other human activities that has caused this degradation in just 50 years. Then they went on, and the report said, the solutions will be complex. There is no simple fix to these problems, since they arise from the interaction of many recognized challenges, including climate change, biodiversity loss, and land degradation. In other words, the important thing here is that climate change is not an isolated problem we've got over here, land degradation an isolated problem we've got over here, and biodiversity loss an isolated problem we've got over here. These are all part of the same problem. They're all interrelated. And so we have to deal with them as a total systems problem. Furthermore, the loss of species and genetic diversity decreases the resilience of ecosystems. So in other words, not only do we now have these problems, but the resilience of the ecosystem to respond to these problems has now been compromised. And it's been compromised to the level of disturbance that an ecosystem can undergo without crossing a threshold to a different structure and functioning. That's the thing that ought to really scare us. Because we know from the history of evolutionary biology that our planet has undergone some of these major species extinction events at least 5 times in its history. And each time, as E.O. Wilson reminds us, it took about 10 million years for the planet to regenerate itself into something new on that new basis of different kind of system and functioning. And it was always some major species changes that took place because the past species, the new system and structure and functioning was no longer favorable to the past set of species and became favorable to a new set of species. And so consequently now 99.9% of all of the species that ever existed on this planet are extinct now because it's gone through those kinds of crossing those kinds of lines of the different structure and functioning. And so the question we have to ask ourselves as a human species, particularly since we're the latecomers on the planet, is whether or not we really want to risk this kind of change in our planetary system. And will the future structure and functioning still be favorable to mammals like ourselves? And certainly favorable to the kind of agriculture we want to do to feed ourselves. And so that's an issue that we have to deal with. And then it goes on, even more disturbingly, to say more challenges are on the way. At the same time that all of this is happening, it is anticipated that during the next 50 years, demand for food crops will grow by 70 to 85%, and the demand for water between 30 and 85%. And this, of course, because of the anticipated increase in human populations to probably 9 billion people before it starts to decline. So this whole issue of environmental degradation is now no longer something that we have the luxury of simply talking about in coffee shops. This is something, given the fact that it is this real and this imminent for us, we simply have to deal with now, and the kind of agriculture that we decide to have for the future has to begin to contribute to the ecological restoration of these systems. So very quickly, climate change. And the thing about climate change, I think now that's interesting, it's starting to show up in very ordinary farm magazine. This one here from Agri-News, which is a little farm paper published, I think either weekly or bi-weekly in Montana. And in one of the articles recently, they said climate in the western United States in the past year has been a study of contrast. The moisture deficit in Billings in southwestern Montana is equivalent to missing over 1.5 years worth of precipitation in the past 7 years. The drought in southwest Minnesota is more severe and prolonged than the drought that caused the Dust Bowl of the 1930s. Meanwhile, Las Vegas just had its wettest winter on record. Soggy California has now surpassed the precipitation levels of most notorious winters. What is going on here? So we're already starting to see that the climate patterns that we've gotten used to, and again here, the thing that's important about this in terms of our industrial model of agriculture is that when you have a very specialized, simplified, concentrated production system, you need climate that consistently is favorable to that specialization. You know, if you're going to have 92% of your cultivated land in corn and soybeans, as we do in Iowa, you have to have weather that's consistently favorable to corn and soybeans. Corn and soybeans are not going to do well if you have this kind of fluctuating climate. And farmers are starting to see this now, and it's starting to appear in their own literature. Here's another one that came out here just a few weeks ago. Last March was the warmest and driest March in 110 years for the 11 contiguous western states. October, on the other hand, was an all-time standout wet month in the Southwest. The atmospheric circulation that has produced this precipitation looks almost nothing like an El Nino circulation pattern. This has been a major puzzle. Well, it's not a major puzzle, actually. This is a return to more normal climate conditions that the planet had been used to up until about 1940. Okay, so the farm income piece of it. You know, there have been so many articles recently, at least in the press in the United States, and I suspect you may have had similar ones here in Canada, about the fact that, you know, farm populations have now stabilized. In the United States, we still have 2 million farmers, and it's been about that for the last decade. So, and the net income of farm families is now slightly higher than the net income of non-farm families, and so the implication is that you know, there's no problem here. Well, in point of fact, when you look at the data in terms of the farm income and the kind of economic situation that farmers are in terms of their farming operation, you have a very different kind of picture. If you look at it in terms of constant dollars, this is based on 1982, 1984 dollars in the United States. Going back to 1949, you will notice that farmers have been fairly successful in maintaining their gross income. And that's the top line. Although gross income from about the middle of 1980, which starts, you know, where the line starts to level off at the end there, includes government subsidies. So if you took the government subsidies out, then in fact your gross income would drop to some extent. But here's the important thing, that while farmers have been successful in maintaining their gross income, they've done it at a total expense, which has increasingly eaten up more of that gross income. So if you look at it in terms of 1949, you know, total expenses were, you know, somewhere around 30% of their gross income, and then it gradually starts to eat up more of that, and which, of course, predictably then means that, predictably then means that your net income is remaining essentially flat. In fact, as of 2003, net income is slightly lower than it was in 1949. That's the real situation we've got to pay attention to. And if farmers are in that situation, if your net income has remained flat, that means that all you're doing is paying for the cost of producing the products that you're producing, and there's very little left for depreciation and family expenses and those kinds of things. And so increasingly what farmers are doing as a survival strategy is increasingly having some members of the farm family work off the farm for the living expenses. In Iowa now, 62% of our farm families have off-farm jobs. Or getting bigger each year to generate more income to pay last year's bills. So you rent more land, add more animals, generate more income, pay last year's bills. That's the fundamental survival strategy. That is not a basis for having the kind of financial capital that's going to enable farmers to respond to the challenges that we're facing in the future. Now, in Canada, I gather the situation is quite similar. This was a report that appeared in the National Farmers Union publication, The Myth of Efficiency, in which they pointed out that per farm adjusted for inflation net income today are lowest than since the 1930s. And so you have a very similar pattern in which your net income is remaining flat or slightly decreasing. So I suspect the statistics here are very similar to what they are in the United States. Now, the important thing, too, to recognize about this is what this is doing to the structure of farm agriculture. And in the United States, we have our national census, which we do every 5 years. And so the most recent one is 2002. The one prior to that was 1997. So yes, we still have about 2 million farmers in the United States, but when you look at where the production is coming from, we only have 163,000 farmers that are producing 61% of our total production. And we'd have another 575,000 farmers that are producing 30%. And then we have 1.3 million farmers, but they only produce 99%. And those are essentially the hobby farmers. So what we need to look at in terms of meeting the challenges of the future of agriculture is this roughly 700,000 group of farmers here. Now, when you jump to 2002, here's what we're seeing. So in just 5 years now, we've dropped to 70,000 farmers instead of 163,000 that are producing 61%. We now have 381,000 instead of 575 that are producing now a little over 30%. And now we're at 1.7 million, but they're only producing 7%. So the question we have to, and maybe this is okay, but the question we have to ask ourselves, again, going back to the kind of capital that we need to maintain, or to meet the challenge of maintaining productivity, is this kind of direction that we're moving in terms of much higher concentration by smaller numbers of people, more centralized management. Are they going to be able to know the land well, to know how to use it well, to be motivated to use it well, to be able to afford to use it well? And I think there's some serious questions about that we have to ask ourselves, and so we have to address this question of structured agriculture. And what that's doing then, consequently, and this is now Iowa, just looking at Iowa, but most other states have a very similar pattern, is that, again, in that 5-year period from 1979 to 2002, here we're seeing that increase in the farms with gross sales of over $500,000, the increase of the very small farms, the hobby farms, and sales under $5,000. Everything else, we're losing. And so losing it at that rate means that we don't have a lot of time left if we feel that the human capital of the particular kind of farmers that we have on the land is important to meeting the challenges of the future. And we have to address this. So finally, the other piece of statistics that I want us to spend a little bit of time with is the age distribution of our farmers. Back in 1910, we had almost 30% of our farmers were under age 35, and about 8% of our farmers were over age 65. So jump up to 2002, we now have 27% of our farmers are over age 65, and only 6% of our farmers are under age 35. So again, the question which that raises is where is the future human capital coming from to meet the challenges that we're facing in agriculture? And of course, part of the way in which we've structured our agriculture with this specialization, simplification, and concentration is that now, because of the farm size, it is now such a capital investment in order to get into farming that beginning farmers can't get in. And so we have to raise the question of how do we make it possible for the next generation of farmers to produce the kind of food that we need in the way that we need it to maintain and, in fact, increase productivity if we're going to meet the challenges as the UN report indicates. Okay, so here's the fundamental question. How much longer can we continue with the current paradigm? And, whenever you ask questions about those kind of large, paradigm kinds of questions, I like to listen to our anthropologists, because they're used to looking at issues from this kind of broad-based perspective. And so here is a graphic put together by Ricardo Salvador at Iowa State University, based on the study of Ernest Shusky in a book called Culture and Agriculture, which was published back in 1989. It's a fantastic study. And what Ernest Shusky does is he wants us to look at answering this question, how much longer can we continue with our current system of agriculture, by looking at agriculture from its beginning about 10,000 years ago, and then projecting it ahead, for the next 6,000 years or so. So let's look at it in terms of that time scale, and then what do we see? And then he points out that from its beginning, about 8,000 BC, up until about the middle of the last century, we were operating on the basis of what anthropologists call the Neolithic approach, and that is using primarily human energy and animal energy to produce the food that we need. And this was a relatively efficient system. We were getting about 10 calories of food for every calorie of energy that we invested in making that available. The most efficient, as he points out, actually was the hunter-gatherers, where all we did was harvest. We were getting about 20 calories of energy for every calorie of energy, or 20 calories of food for every calorie of energy invested. And so that's basically the way we did it. And then he says, we introduced, about the middle of the last century, what he calls the neocaloric era. I love that term because it really describes what it is, doesn't it? It's heavily dependent on calories to fuel the system. Fossil fuel calories, stable soil systems, all those natural resources that were accumulated on this planet, over the several billion years of life since life evolved on this planet. And he argues that this will, of necessity, be a very short period of time in terms of that long sweep of history because they're old calories. In other words, these are calories that have been stored up in nature, and we are now mining them to fuel our current human economies, including agriculture. And because we're mining them much, much faster than nature was able to accumulate them, it's going to come to an end. So the real question is, when is that end point? And then the big question is, what's the next era? So when you think about it in these terms, it really forces us to really use our imaginations and say, okay, we're headed toward a new kind of future here with a new set of variables where we aren't going to be dependent on those old calories. So how do we do agriculture? How do we maintain productivity indefinitely into the future under these new circumstances, since we don't have those calories available anymore? Well, here is a couple of Japanese agroecologists in a book which they edited, published in 2001, called Structure and Function in Agroecosystem Design and Management. And I think that they ask the critical question that we need to be dealing with. They say, is it possible to replace current technologies based on fossil energy with proper interactions operating between crop, livestock, and other organisms to enhance agricultural production? I think that's one of the most interesting questions facing agriculture today. Unfortunately, most of our research institutions are not paying much attention to that question. And that's the challenge which I want to leave with you. It's the challenge I'm presenting to my staff in our center and to Iowa State University and to anybody else that's willing to listen, because I think that's the fundamental question. Now, they go on to say, if the answer is yes, then modern agriculture, which uses only the simplest biotic responses, okay, simplification, specialization, concentration, can be transformed into an alternative system of agriculture in which the use of complex biotic interactions becomes the key technology. Now, that's a proposal I think we ought to explore. That has the potential, I think, to be that next era in agricultural systems. So the question then is this just a lot of pie in the sky, or does this have some real on-the-ground relevance? Well, what I'd like to share with you now for the rest of our time together here is some real farmers who are actually answering that question. And again, I'm not here to glorify farmers and say they're always the innovators who are on the front lines, because that isn't always true. But there usually are a few farmers who get it early because they know that the current system's not working, and they start to explore and experiment on their own farms with some new directions. So, 3 examples. Here is a farmer in southern Japan. His name is Takawa Furuno. And as he tells his story, he was a typical modern industrial agriculture farmer raising monoculture rice. That was his specialty. That was his specialization. He had simplified his system by using fertilizers and pesticides like all farmers. And he, for his farm in southern Japan, has done a pretty good job of the concentration issue. It's a small farm certainly by Alberta standards and by North Dakota standards, but for southern Japan, it's a fairly sizable farm. So there he was, and as he says, in 1987, it suddenly occurred to him as a farmer that every year, everything that he earned on his farm, he had to reinvest in the next year's crop to produce the next crop. He didn't get to keep anything. He said, this is no fun. Why am I doing this? And so he decided he began to wonder whether there was another way to approach this. And so he came up with a simple idea, and that is to marry the wisdom of the past. How did farmers do this in the past? What mechanisms did they use before industrial agriculture took hold? And then if we marry that with the best science that we have today, could we come up with something entirely different? Well, here's what he came up with. The first thing he noticed in looking at the wisdom from the past is that farmers in the past in Japan used to raise ducks in the rice paddies. So he began to wonder, what was that about? So he decided, fine, he gets a piece of electric plastic fence, puts it down in the middle of his rice paddy, puts these little ducklings in, and then just sat back to watch. And And what he noticed was that these little guys were starting to eat the insects off of the rice plants. So he begins to wonder, if I had the right kind of breed of ducks and enough ducks in my rice paddies, would they take care of the insect problem? I wouldn't need to buy an insecticide anymore and reduce my costs. So he begins to experiment. He discovers from the best breeding available that the cross between a wild drake and a domesticated female make the best insect grazers. And then he discovers that about 200 ducks per hectare, they take care of the insect problem. So now he's got the ducks in his rice paddies, he doesn't need to buy an insecticide anymore. So he figures that's pretty cool. So what else can I learn from the past? Well, in the past, farmers in many parts of the world in rice-growing areas used to raise fish in their rice paddies. And then when they started using insecticides to control the insects, of course, they killed the fish, so they couldn't raise fish anymore, so mostly they gave that up. So he began to wonder, now, since he's not using insecticide anymore, could he also have fish in his rice paddies in addition to the ducks? Well, the experts all said, you got to make a choice, because if you put those little fingerling fish into the rice paddies with the little ducklings will dive down and eat the fish, so you got to make a choice. It's either ducks or fish, you can't do both. So again, he decides to experiment. So he gets a tub of water, puts in some little fingerling loaches, which are the preferred fish for rice paddies, and puts the ducklings in. Sure enough, the ducklings dive down and eat the fish. But then he thinks, rice paddies are a little different because the water's cloudy. Would they still do it with cloudy water? Gets a few handfuls of soil, puts it into the water, stirs it up, put the fingerlings back in, put the ducklings back in. Ducklings don't eat the fish anymore. So he begins to experiment again in the rice paddies. And begins to discover that actually the fish and the ducks are quite compatible. And now he notices another effect from this. He noticed that green growth at the top of the rice paddy there. That's a plant called an azolla. It's a fern-like plant that grows very much like a water lily. So you start out with 2 plants, and then 4, and then 8, and then 16. And by the time your pond is half covered in a matter of days, of course it covers the whole pond, chokes everything else out. And this is exactly what farmers were experiencing in their rice paddies. So farmers routinely use an herbicide to kill off the azolla. But now with both ducks and fish in the rice paddies, they both feed on the azolla, so they keep it under control. But the azolla, because its relationship with bacteria, also produces nitrogen. And so now, the nitrogen from the azolla, which he now actually plants in his rice paddies to have enough of it, the nitrogen from the azolla plus the droppings from the ducks and the fish provides him with all the fertility he needs, so he no longer needs to buy a fertilizer. Again, reduce the cost. So now, instead of being a rice farmer, he's a farmer that produces rice, duck meat, also duck eggs, which he also harvests, fish meat, and fruit. Since he's no longer using pesticides, he can now grow fruit trees on the periphery of the rice paddies again, the way farmers in ancient times used to do. So now get the picture here? He has dramatically increased his productivity because instead of producing one product, he's now producing these range of products, and he's doing it at dramatically lower cost. So he's increased his profitability, increased his production. So he's not just maintaining productivity, he's actually dramatically increasing his productivity, but doing it in a way that's ecologically sound because there is almost nothing going on in his system that's degrading the environment. Now, is that a model for the future? Now, I'm not suggesting that we're going to start growing rice and ducks and fish in Alberta or North Dakota, but what's the ecological equivalent for our ecosystem? What are the species that thrive well here? What are those biological synergies among those species that are possible for us to explore? Now, Verona discovers another thing. His rice yields start to increase over against the old system. He's trying to figure out why that happens. And then he notices that the root crowns, these 2 plants here are now from the new system, this integrated system. You notice the root crowns are quite large. These are the plants from the old industrial system. The root crowns are much smaller, so of course you have less tillering, therefore less rice. He's not even sure why this is happening. There's something about the synergy of the system now that has caused the root system of the right plants to grow larger and therefore increase. So his rice yields now, in addition to these increased products which he's growing, his rice yields have now increased between 20 and 50%. So it seems to me that there's a model here that's worth exploring as we think about what's the next era of agriculture. And Takao Verona has now written a book about this in which he documents all of his experiments and everything he's done. It's a delightful little book called The Power of Duck. And he has, the book is published by Tagari Press in Australia, but it's available through Rodale Books in the United States and probably available here in the United States as well. But in his book, he points out what the concept, what the principle is behind this. He said the concept is to produce a variety of products with a limited space to achieve maximum overall productivity. But this does not consist in merely assembling all of the components. It consists of allowing all of the components to influence each other positively in a relationship of symbiotic production. Now remember the question that was raised, could we have an agricultural system in which you have these symbiotic relationships of species, crops, livestock, and other species, to increase productivity? And Takao Furuno is saying yes, at least in this instance, producing ducks, rice, fish, fruit instead of just rice. This is a doable thing on the ground. Okay, second example. This takes us now to a different part of the world, into Latin America. And there's a project that's being conducted now by the Equilibrium Fund Maya Nut Program. And it's a project that's being carried on primarily among women. Women are a key factor in many parts of the world in terms of the kind of agriculture we're talking about. And I'm indebted to Erica Bowman for sharing her slides of that project with me. So what's a Maya nut tree? Well, Maya nut tree is a forest tree, grows quite large. It was the staple food for pre-Columbian hunter-gatherers, again going back to the hunter-gatherer area. It's quite nutritious and delicious and easy to harvest, and it maintains the ecological health of the land. Now, one of the things that this project has done is taken a look at the nutritional quality and productivity of the Maya nut tree compared with corn and wheat and rice. Because one of the things that's happening now is people are cutting down the Maya nut tree for firewood and other uses, and then planting the land into corn, thinking that they're making headway here. And of course, what they've pointed out is that looking at it from the point of view of protein, calcium and iron, etc., the Maya nut actually outperforms corn, rice, and wheat by a considerable margin. So actually, there's a decrease in terms of nutrient availability in going from the Maya nut tree to the cereal grains. And also, in terms of vitamin content, the Maya nut is superior in every respect with the exception of vitamin A, where corn actually outperforms the Maya nut tree. But again, as an overall food product, clearly dealing with a superior product here. And the same is true with amino acids, etc. Again, the Maya nut outperforming the other grains. And then in addition to that, the Maya nut produces 4 times more food and 10 times more protein per hectare than corn does. So, what they're trying to do with this project is point out to the local people, and especially the women, that by taking out the Maya nut trees and replacing it with the more traditional kind of cropping systems, they're actually losing the very thing that they need to be developing in order to maintain productivity, and going back to that maintaining productivity issue. And then, of course, in addition to that, the Maya nut tree protects the soil and water and biodiversity. So here again, you have this win-win situation where you're increasing productivity, decreasing your costs, and restoring the ecology of the land at the same time. And then they also go on to point out that the Maya nut is very usable for different kinds of food products, lends itself very well to their traditional dishes, like tortillas. I love that one statement. Since I started cooking with Maya nut, my children ask for it every day. They love it and they seem livelier, which may not be something that some parents want. But nevertheless, there it is. And here they are. Here are the women that have gone through the program and have learned about all of this. And this statement at the bottom here, I think, really tells it all. Your husbands will never cut another Maya nut tree for firewood. So these are this is that social capital. This is the development of social capital, motivating the farmers to produce the kind of agriculture that we need. So finally, a little experiment going on in Iowa. A couple of middle-aged farmers who are looking at some of these integrated systems. Again, looking at this, how can a multiplicity of species work together? This is a very small project, but it's quite interesting. And what they've done is built this netted system with a net covering it. and they're growing, raising a combination of grapes and corn and poultry. And then on the fringes, you usually have some additional food crops. Now, what's interesting about that is that this combination of corn and grapes, so this kind of alley cropping where you have the grapes down the middle and between the rows of sweet corn, these are very compatible with one another. There's some synergies going on here. And then the poultry, and they use either chickens and or pheasants as the poultry in this. The poultry take care of all of the insects. They help reduce the weed problems. And after the sweet corn is harvested, they cut down the stalks, and then of course the chickens feed on that. So they need very little supplemental feed for the chickens. Chickens get most of their feed, in other words, from the resources in the system. So again, it's that biological synergy. There they are when the sweet corn has all been harvested and the stalks cut down. And as you can see, the chickens do very well in that circumstance. And here a little more mature, with the grapes growing. And as you can see, a very common system. And the grapes look to me like they'd be worth eating. And here's the interesting thing. On a per acre basis, they're generating $10,000 an acre. Now, I would challenge any corn soybean farmer in Iowa to be generating that, on a per acre basis. So there's the potential here for increasing the profitability of farmers. So as we think about the future, what are the basic operating principles, the features that we need to think about? And I want to leave you with these 8. I made a mistake here. I didn't realize this until I was on the plane, checking my PowerPoint, and I've got biological synergies in here twice, so I need to correct this number 6 here. So it seems to me that if we're going to meet the challenges that we're looking at, we need systems that are energy conserving, and I think that's a key one, and that one's going to hit us fast now. Farmers cannot continue to absorb these increasing energy costs, which we're going to see. There are going to be some jumps up and down, as in any system there are, but the trend is going to continue to be up. So we got to come up with energy conserving systems. Secondly, I think we need systems that are driven by biological synergies. There is no other alternative currently where you can switch from fossil fuels to a different kind of energy. It's just the efficiency is not there. As Paul Roberts, who wrote the book, The End of Oil, and the basis of his book, incidentally, is based on research that he did on the ground. He traveled all over the world and visited all of the oil-producing states. And he said the situation that we're facing now is similar to the situation that we faced when we transitioned from wood to coal, and then again from coal to oil. The only difference is that in addition to all of the and difficulties of making those transitions, we now have to make the transition from oil to what? There's no next obvious energy source that we can move to, and that's our situation. So it seems to me that biological synergies that's part of that conserving energy that seems to me to be the most viable option. We've got a lot of research to do to figure out how a Takao Faruna kind of system or a Maya system fits into agriculture here in Alberta and fits into agriculture in North Dakota and Iowa, California, and Florida, and other parts of the world. These systems have to be largely self-regulating and self-renewing. This is how nature's system works. We capture those principles. If we have to constantly being the therapeutic intervention, it's not going to get us where we need to go. It's going to continue to be energy intensive. We continue to create part of the problem we're solving. We now have to shift to these systems that are essentially self-renewing and self-regulating. And those systems have to have interdependence in them. Again, this is how nature functions. Nature doesn't have a healthy ecology without the interdependence of the various species that are part of a local ecosystem. And we have to, in our thinking, in our cultural thinking, now shift from this division between extraction and preservation, which is kind of how we've operated in the past. So we have the agriculturalists, the farmers are the extraction people, and they do things over here, and the environmentalists and the conservationists are the preservation people, and they're preserving land over here. We're now at a point where we're just starting to recognize that's not working for either group. Because the preservationists can't meet their goals. We're still losing too many species in our wilderness areas. because as we've learned now, passive ecology doesn't work. Nature is all tied together, it's all interdependent. And so you can't maintain a healthy ecology in isolation. And farmers are just starting to realize, and we'll realize more as energy costs go up, that they can't maintain a healthy, productive farm without the vibrant production of a healthy ecological system and healthy biological organisms. And so for the first time now, we're starting to see farmers and environmentalists having conversations with one another, just starting. Ranchers and environmentalists in Western Plains, for example, over the last year and a half, have had some very interesting conversations around how to manage grazing systems that are both environmentally productive and serve as that are both economically productive for the ranchers and serve as a habitat for the kind of wildlife that the environmentalists want to preserve. So we are now at a point where we can move from this extraction preservation model to ecological restoration model in which we all have a stake, especially if we take the UN report seriously. And then the sixth part, and this is the part I want to change that, what I intended to say there was biological and genetic, has to be based on biological and genetic diversity. And within that, nutrient density. Now the reason that our biological and genetic diversity has become so simplified is because, again, we've operated on this model of specialization, simplification, and concentration. So we have dramatically reduced the biological diversity that we depend on and the genetic diversity that we depend on for our food production. Because in our genetics, what we have done is develop species of plants and animals that do just one thing, and that's primarily increase the yield. And we have not looked at those other services that we need from a more diverse genetic pool and a more diverse biology. Because the resilience of the planet is ultimately based on the diversity, our biological diversity. If we don't have that, then we continue to have these compromised ecologies that are not going to be able to respond to the new challenges that are coming at us. And then the nutrient density is important because if we're going to meet the challenge of this increasing food production, we're not going to get there by simply trying to rev up the yields of corn and soybeans and wheat and rice. We can't get there that way. Even with all of the new technologies, there is no real solid hope that we can meet the challenge of the increasing human population. It's going to have to be through nutrient density, like the Maya nut tree, and those kinds of species. You know, if we were really interested in producing more nutrient value, we would not be using prime farmland to raise iceberg lettuce, for example, which has almost no nutrient value at all. So we have to look at the kinds of foods that we produce that are nutrient dense, that are based on these kinds of biological diversities. And then, instead of control management, adaptive management. And again, this is how nature functions. Nature is not in a control situation. Nature functions in terms of adapting to changes as they occur. And changes always occur because we are living on a very dynamic, very vibrant living system that has emergent properties. Things are constantly changing. And so the only effective management tool in that kind of environment is adaptive management. How do we adapt to those changes as we move along? Control management is going to be increasingly dysfunctional. And then finally, the eighth principle is that adequate food production based on nutrient density and multi-product synergistic production rather than monoculture yield and increased land use. So that's sort of the summation of these kinds of principles. So that's where I want, that's my, way of, that's where I'm at in my thinking at this point. And so let's open it for questions and see if you have, and I tell people I'm a Russian German by ancestry, and I haven't had a good day unless I had at least one argument. So I hope you're not.
I work on pastures, which can be fairly dynamic. I set up, one on each side. I invite people to move to the microphones to ask their questions so that everybody can hear you. If there's somebody who can't move to the microphone, wave at me and I'll come down with my mic and you can ask your question from the seat. So maybe I'll just give you a chance to move to the microphones and maybe
You have a question.
I have a couple actually. Maybe I'll ask them in reverse order, because you mentioned iceberg lettuce. I was reading in a British newspaper recently that horticulture people for market gardeners producing vegetables for supermarkets are throwing away about 60% of their crop because the supermarkets don't like the size, the shape, the color, whatever of the product. Do you have a comment about how we as consumers are affected this whole picture?
Sure, and we have enormous waste in our system. And again, if one of our objectives is to produce adequate amounts of food to meet a growing population, and incidentally, I personally take very strong exception to the notion of controlling population. You know, it's sort of been the mantra that we've had for, the last 40 years or so. And I don't think controlling population works in the first place. But in the second place, what we're really doing then is we're saying it's all the fault of people in the developing world because that's where the most population growth is. And the issue really fundamentally, ultimately, is not at this point producing enough food. It is making resources available so that people have the income levels to produce or acquire the food that they need. We're producing enough food right now to provide adequate calories for every man, woman, and child on this planet. That's not the problem. And so we have to begin this issue from this larger perspective. But nevertheless, we still have this issue that you're raising, and that is, how do we make the best use of the food that we're currently producing, plus, increasing the nutrient density, et cetera. And we are currently, in our modern Western agricultural food systems, losing about 25% to waste, simply because of the way the system is put together. And to me, that's unconscionable. I mean, I grew up in a family where if you didn't clean up your plate, you were a bad kid. And so wasting food was, a terrible thing to do. And so I come out of that kind of ethical framework. So, I think it's not just that we've gotten used to the notion that, things have to be, exactly the same size and all of these aesthetic qualities, et cetera. And in the process, but here again is the good news, in the process, we have sacrificed some of the things that many of us really want in food, things like good taste and some of those things. And so now there's beginning to be a revolution in the food system. And it's taking place primarily in food service, but starting to take place in other places as well. And I think this is a place where the market will support the kind of transitions we need to make. Because in the marketplace now, there are three things which are increasingly in demand. One is the quality of the food, and it isn't the beauty and the shape of the food, et cetera, but its taste, its health, and its those are always top on the list of people that are now concerned about quality of food. And then in addition to that, it's the food story that comes with the food. People want to know, they would prefer to know the farmer that it came. One of the reasons that farmers markets have been developing so rapidly is because people shake the hands of the farmer that grew the food. And there's that notion. So, and they want to know that there was good environmental stewardship. They want to know that the animals were treated appropriately. So you add value to the food product by making those connections. That again plays into and provides market support, the kind of direction I've been talking about. And then the third thing that they want is a relationship that they can trust. The Hartman report recently, a most recent report, said that increasingly now consumers no longer respond to companies who market at them. They respond to food companies that market with them, that include consumers in the marketing system. So I think we're going to get past this notion of, I'm only going to buy things if it's uniform size and shape and color and all of that, because increasingly now there's a population that says, we have obesity and diabetes that is growing at a rapid rate. So what am I feeding my kids? That's contributing to this kind of dietary problem. And how can we have a really good eating experience? I haven't had a peach that tastes really wine. Where can I get one? And if it happens to be a little smaller or uneven size, it's not going to be the important thing. If you notice this about apples, the red delicious apple, which has it's absolutely uniform in size and color and all that. that's not what people choose anymore. You know, they're choosing something that don't look quite as pretty, but that tastes good. And I do. And you probably do too.
You have a question?
Yeah, Keith Briggs, Prof Emeritus from this faculty. My question is about water availability, dry land, and irrigation. We know that plant productivity only occurs where the water is, and that's where most of where the water isn't is our big dryland areas with our big crops and farmers going bankrupt. If there is a carry-through on these 8 things, do you see there's going to have to be political intervention to promote dryland farming and to can irrigated farming? Because locally or internationally, the trend is otherwise.
Yeah, thank you for bringing that up. I mean, there's a number of other things that I could have included in this, but I knew I was going to run out of time if I added them in. You know, we also have the issue of the increase in infectious diseases. You know, 35 new diseases in the last 30 years, and the scientists that have explored this have now said ecological impact is one of the major causes. So it's another issue. But yeah, the water issue is clearly you know, another one of those challenges we have to face. 70% of the fresh water used in this now is for agriculture, and in most of our aquifers, we are drawing down the water faster than nature is recharging them. The Ogallala aquifer in the Midwest, which I'm most acquainted with, you know, we're drawing that down at the rate of about 126% faster than nature can recharge it. So again, we're heading toward a future where that resource, if we don't manage it better, and here again is where conservation is going to come into the picture, we have to find more water-serving ways. And this gets us into what you all are doing here so well, and that's dealing with the whole issue of soil quality. Because when you have good quality soil that is porous, that absorbs more water and retains more water, then you don't need as much irrigation water because the system, you know, retains that water. So again, it's all connected. So again, our future systems have to be systems which are not only more energy conserving but also more water conserving. You're absolutely right about that.
I'd like to just give you an example of the problems that we as farmers face. I'm a dairy farmer, and if I drink raw milk and take it out of my bulk tank, I'm breaking the law. Now this sort of thinking just makes it all that more difficult to move to where you're suggesting.
Yeah, that's, I mean, we, you know, at my center now, we're saying that we've organized our research work, the research work that we fund, around 3 initiatives. One is these kinds of new biological systems. How do we give farmers the tools to begin to do that? Second is what kinds of new markets can we develop that enable farmers to produce more value and retain more of that value in the farm. You know, we've all heard about value-added agriculture for a long time, and the problem is the farmers have forgotten to ask about where the value gets added, right? It usually gets added further up the food chain. And we're saying there have to be systems where farmers retain more of the value in the farm. And again, some of these new markets we're talking about, we can do that. And then the third piece of it is what kinds of policies do we need to put in place that, at the very least, do not serve as barriers to farmers making these transitions, but hopefully serve as incentives to making those transitions. And the example which you used is certainly one. And again, you know, none of us as farmers are in favor of production systems that put our customers at risk. You know, so we want to maintain good health standards, et cetera. But I agree with you about the raw milk. You know, I grew up drinking raw milk all my life, and I turned out okay. But you know, we didn't. You know, we took care to make sure that there was cleanliness and all of those kinds of things. So you know, we need to explore. And my guess is that again, some of this policy change incentive is going to come from more regional efforts because there's so many interests now at the national level. I mean, I'm sure this is true in Canada, certainly true in the United States, that it's now very difficult to get change in any kind of policies at the federal level. But it's more likely to happen at the township level, the county level, at the provincial level. And so begin to have some conversations and they have to be conversations that include our urban and suburban citizens, because that's where the primary political power is. And what I've discovered is that when people in our urban and suburban centers recognize that a food issue affects them directly, they can get involved in food and agriculture issues pretty quickly. Right now, most of our citizens don't see the connection with what's happening on the farm, and that's part of what we have to work on and correcting. And I'm not saying the farmers have the responsibility to this themselves. The farmers need to be at the table to some extent, but we all have to. This is now, when you look at what the UN Ecosystem Assessment Report is telling us, this is everybody's problem. This is not just the problem of farmers. And so we have to work together to find those solutions and create the incentives and have systems that are as free as possible. Because, if you have unnecessary regulations, then, that stands in the way of innovation and prevents farmers from doing the kind of things they're capable of doing.
There are huge economic and fossil fuel costs associated with nitrogen fertilization of crops, for example, corn. Any suggestions on biological synergies that you would see to reduce the anhydrous and urea use on crops such as corn?
Yeah. Well, I talked to your Jeanette, where are you, with the Pulse, the Alberta Pulse Growers Association. I think some of the things that you're doing there in terms of, you're talking about the fact that if you could raise pulses that produce nitrogen, then, provide the nitrogen, or at least a good part of the nitrogen in corn, then you begin to reduce that. So again, it's that kind of, those kind of biological synergies. Now, I don't think that we have yet really looked at the potential complexity of those kinds of systems. Now, again, and I'm a farmer too, and I don't particularly like complexity, although at some level I like the challenge, and if I have the wiggle room to begin to try out some of these things, then I'm willing to do it. So we need to, I think, explore what are the best kind of synergies. But some of these things we know. We know how to fix nitrogen. Phosphorus may be a more difficult problem. So if we can begin to experiment, but then the other critical thing is we have to have markets for these crops. And again, I know Iowa best now, and it's even difficult for farmers to raise wheat in Iowa because you got to truck it about 200 miles to find a place to deliver it because all the local elevators handle is corn and soybeans. So we have to look at these as systems problems. And the thing we can do, or need to do, or want to do, is to simply say to farmers it's their responsibility because they simply do not have the time, the financial resources, or the market outlets to make these changes under the circumstances. So we got to work at this together and create the possibilities. And my experience is that farmers are radical pragmatists, and when they see that something works on the ground, they will adopt it and they'll adopt it rapidly. So this is why we need the research community to explore exactly the things that you're talking about. But I'm convinced, based on other models that are around, that those biological resources are there in every ecosystem. We just haven't. For example, in my farm in North Dakota, I know very little about how the ecology of the prairie functions. It's never been a part of my education. It's not a part of the research agenda for North Dakota State University now. There's a very small part of the department in doing some prairie research where they're starting to do that. They're not in conversation with the College of Agriculture. So we need to understand how these natural ecologies work. What are the resources available, and how can we apply them to agriculture? And the enrichment of the soil is always at the foundation of all that.
Thank you very much. I think it's probably time to draw the
Okay.
question period to a close. I do have one little question for you, if I may sneak it in.
Sure.
You've been talking in conclusion here about the necessity to look at the system as a whole. How do we get the funders to give us money to look at that kind of a situation? Do you have a silver bullet for us?
Yeah, well, so that gets us really right to the basis of the theories of change, right? And, I think most of us in Western culture, at least, we still kind of believe that change happens in the Lone Ranger model, right? So, somebody comes in with a great idea, and, they ride into town, and 6 guns blazing, and vanquish evil and establish good, and they can ride off the sunset, and everything's fine. But if you look at it historically, change doesn't really happen that way. Change does not happen because a group of people get together with a really great, wonderful idea. They convince everybody then that they ought to adopt. Change almost always happens because of a convergence of events that take place that are beyond anyone's control. But then what we need in place those intelligent intelligent ideas, etc., which then become the lever for moving us in the right direction. And that's where we are now. You know, the changes that you're talking about are not going to happen simply because we decide here that they ought to happen. But the most immediate driver for change, I think, is going to be energy. Because we cannot my guess, if I were to make a guess, I would say within the next 5 to 8 years, we're going to have some fundamental changes in agriculture simply because the cost of fossil fuel energy is not going to be doable. So the question is, are we in the research community going to be ready with those ideas that farmers can adopt when they start to feel that pressure having to change? And it's not just the farmers, but the whole system has to change. Because farmers can't do it by themselves. Or should we expect that? So how do we then use these new ideas for the future, these new models, that we can then roll out and say, there's a better way to do it, there's a better way to solve the puzzle, and then the community can respond to that. If you think about the civil rights movement in the United States, we often credit Martin Luther King for bringing sort of a lone ranger, bringing the civil rights movement. He himself denied that was true. But I've always argued that if Martin Luther King had appeared on the scene 40 years earlier, he would have probably been a footnote in history because the course of events had not converged yet to make things ready. The brilliance of Martin Luther King was that he recognized when those convergent events came together and had the moral fortitude, the ideas for how we could move into a new era of civil rights. And it was that convergence of events and the public coming together around that fundamentally changed civil rights legislation in the United States. I think that's a model that we need to look at, how we bring about the kinds of momentous changes that we need to bring about.
Thank you very much. I'd like to invite Dr. Erasmus O'Kine to come give some concluding remarks.
Okay, great.
And thank Dr. Kirshenmann.
Ladies and gentlemen, I think we should say thank you again in terms of a big applause to Dr. Frederick Kirshenmann in terms of a wonderful, brilliant talk this evening. My duty here is quite simple. I added to what he was saying and bring it into context in terms of what Dr. Fred Bentley wanted. That is what I'm supposed to do. Fred began by giving us a very simple definition of sustainability. So simple, in fact, that you think it was very easy and that there was no need for him to even continue with his talk. It was a very simple definition which involved the land, fertility, and ecological health. It became a little bit more complicated. He brought in the fact that knowledge, motivation, time, the financial capital to be able to have a sustainable agriculture. He even complicated it a little bit more when he brought in the human and social components of sustainability. He went on to tell us that in terms of the agriculture as we know it right now, there were some basic assumptions. That yes, we've done very well in terms of production efficiency, but we've done it through specialization, simplification, and concentration. And he said that model worked and continues to work very well in the manufacturing industries. He gave a Ford principle, for example. And he began to question whether the same model would work for agriculture. He laid out, in very simple terms, the challenges he saw ahead in terms of fossil fuel, degradation, climate change, and what he termed the bankruptcy in terms of the producers of our food. He explained in detail what he called fossil fuel, or shortage of fossil fuel, which is supposed to be coming. He hinted that the way was not necessarily to find more ways of fossil fuel, even including renewable fuel, but to look at it in terms of degradation. In terms of environmental degradation, Fred went on to tell us that 60% of our ecosystems are being degraded, and that there's going to be growing pressure in terms of even our water demand increasing by 30 to 85%. He emphasized that even in terms of the highly technological access that we've had, net income has declined or nearly constant in terms of Americans, and if we compare it to constant numbers, 1982 to 1984 numbers. For Canada, it says it is constant if you go back as far as the 1930s. So the assumption that large farms is the way to go, but with declining capital, it's not going to serve us very well. He emphasized that even if we're so productive, how long could we continue with this particular system? And he described it as a Neolithic, the neocaloric, or some other kind of solution to turn our problem. He looked then into the future, and he said that one way was to have a proper interaction between capital to enhance agricultural production. And one simple model was a simple biotic responses and interactions. Then he went on to give us, in his brilliant way, examples, where he said that try and marry the wisdom of the past with the science of today to ensure that we had a diversity within symbiotic relationships. Then he gave us examples of the Rune, the Japanese fellow who had written The Power of the Duck, and how simple the system was and how complicated it was if you looked at it. He also gave us examples of the Maya nut program in Colombia. And then he gave us a third example of the corn, grapes, and poultry, where they were using those very simple techniques of marrying them of the past and the science of the present and future to make about $10,000 per acre. And he challenged us to see whether the traditional ways of doing it would capture the same value of about $10,000 per acre. As I was listening to him, I was listening in context of the strategic directions of Faculty of Agriculture, Forest and Economics. That we have 4 pillars where we will have to work together to have healthy environments as you see them. That enhancing global food systems work together to increase the biodiversity of agriculture as we know it. We also have a strategic direction in terms of building the bioproduct industry and trying to enhance the value to get from agricultural systems right now. And last but not the least, we have a pillar which says that we will be looking at sustainable land, forest, and water management. And I have to say that as I listened to Fred, it dawned on me that the concept of biodiversity and through the concept of ecosystem service and human being, this faculty is well placed to be able to meet the challenges as he has ascribed. If you look at the 8 pillars that he says is the way to forever move forward in the post-industrial agriculture. Let's say thank you to him again, and please come forward for the presentation. Fred, we say thank you to for this evening, and we'll take a word of inspiration. Thank you very much.
Thank you so much. The time I was in Canada and was getting packages and stuff, and it included in it some bison jerky. They took it away from me at